Good afternoon. All right, so this is our last class day together. We will finish up the review, which again is only a couple more examples. I'm going to show you something in the calculator, though, for how you can check yourself on these integrals. So I haven't shown you that all semester, so I'll make sure I show you that. Other than that, though, that's really all we'll do. So we'll probably finish up early unless you have additional questions that you want to look at. And I'm definitely, available for the entire class period if that's the case. I will still have student hours next week, so if you have any questions about anything before you take your final exam, I will be available during the student hours times. We just won't have any regular class meetings next week. But if you do want to schedule something with me during class time, just let me know because I am available during that time too. Okay. If you haven't already signed up for your exam time, please make sure you go in and do that. Again, the link is in the announcement section. It won't take you more than a minute to do it. So please just make sure you get that done. If you need to change your time or if you forget what time, let me know that too, and I'll be happy to do that for you. Okay. I think that's all in terms of announcements. So any questions, comments, concerns before we finish up the exam review today? Yeah, so today is the last day of class. Like I said, we won't have a regular class meeting next week, but if you need to meet with me for any reason, I will have normal student hours. Or if you want to meet with me during class time, just email me and let me know, and I can definitely set something up for us to meet if you need to. Okay, but yeah, this is our last actual day of class. Any other questions? All right. So I'm going to go back to the part A of example 10 so that we can look at how we could use the calculator to check ourselves on this one. Obviously, on the exam, you're going to have to show all your work and everything, right? But there's a lot of places where you could go wrong, and so it's always nice to kind of be able to check yourself and make sure that you feel confident in your answer. So in your calculator now, I'm going to switch over my view so I can walk through these steps with you. All right, what we're going to do is we're going to go to our y equals and we're going to put in our function so that we can graph it. Okay, so under y equals now, I'm going to put the 2 plus x squared, make sure that's grouped together since it's in the numerator. And then we're going to divide that by the square root of x. Right, so first step, just type in the function as is, so 2 plus x squared divided by square root of x. Now what I'm going to do is I'm going to go ahead and graph it. Now, the next thing we're going to do is we're going to make sure that our window has all of the values that are part of the upper and lower limit. So this time our lower limit was 1, our upper limit was 4. In this case, my window is going from -10 to 10, so I'm good, right? But if your limits go beyond what your window is, adjust your window, and right, you just go to window, change your x min, x max to make that happen. Okay, but your values have to be within your window. Okay, so that's key. So I'm going to go back to my graph now. We're looking for the integral now from 1 to 4 for this function. So if you press second trace, that's our calculate menu. Notice number 7 there says integral of f of x dx. I'm just going to scroll down to my integral of f of x dx. The first thing it asks for is my lower limit. Well, this one says the lower limit's 1, so I'm going to put 1, and I'm going to press enter. And it says, what's your upper limit? Well, that's 4, so I'm going to put 4. I'm going to press enter. It shades the region. It gives us 16.4. That was our answer. Okay. So again, quick, easy way to check yourself for definite integrals only, right? It's not going to do an indefinite one and give you the function itself. But if you're doing definite integrals and you have upper and lower limits, graph the function, go to your calculate menu, select integral, put in your lower and upper limits, and it'll actually shade the area and tell you what that area is. Okay? Any questions about that one? Yeah, so if you go to the math key, and I'm trying to remember, is it number 9 under math? And then you can actually put it in there, right? And again, like, this depends on what type of calculator you're using and what your firmware is, whether this is an option. So that's why the other one I think even works for TI-83 calculators. I think this is only on the 84 plus with upgraded firmware where you can actually type in the upper and lower limits. Okay. So that's why I show you the other way. But yeah, this way works too, where you can just type everything in. Okay. And so, maybe you've already found that and you've already been using it. It's fine, right? Because again, you have stuff to show your steps on your test. But if you need to check your answer, right, this is a good way to do it. Any other questions there? All right. Let's go back to our examples now. All right, so this is where we left off. So part C of example 10, we want to evaluate the integral e to the sine theta cosine theta d theta. All right, so what's our first step going to be to evaluate this integral now? Okay, good. So we need to do a u substitution, and we're going to let it be the exponent on the e value here. So u equals sine theta. And then we can do what? All right, find your u prime, du d theta, which would give us what this time? It's going to be cosine theta. Good. I'm going to come back to my integral. So when I rewrite this now, what's it going to look like? Good, right? So we know that e to the sine theta is just going to become e to the u. That means we're still missing cosine theta d theta. If I solve this over here now, I'm just going to move the d theta to the other side. So now I know that cosine theta d theta is just du, so that becomes a du now. Right. Now that we've got that, now we can find our antiderivative. What's the antiderivative going to look like this time? Just e to the u, right? So the antiderivative of e to the u is e to the u. Indefinite integral this time. So what else do we need? Plus c. Don't forget that plus c. All right, and now that we've got that, now we can just plug our u value back in there. So this becomes e to the sine theta plus c, and that is our answer. Any questions on that one now? All right. This one we've got cosine x over 2 plus sine x dx, and we just want to evaluate that integral. So how would you start this one? All right, so we are going to have to do a u substitution, right? There's no way to simplify this fraction first to help us find the antiderivative. So what would you let u be equal to for this one? Good. We're going to let it equal the denominator, the 2 plus sine x. So now, when we find our du dx this time, what's that going to give us? Good, just cosine x, right? Because the derivative of 2 is 0, derivative of sine is cosine. When I rewrite this, the 2 plus sine of x is in the denominator, so I know I'm going to have a u down here in the denominator, which means I'm missing what now? Good, the cosine x and the dx. Right, so I'm trying to replace this and this. So I'm going to come over here and solve. We get du equals cosine x dx. So what's my integral going to look like now? Good, it's just going to be 1 over u du. Any questions about how we got that? All right, now if we're looking for the antiderivative, what are we going to do next? Good, right? So remember, the antiderivative of 1 over u is just natural log u. Don't forget, it's technically natural log of the absolute value of u, right? So make sure you put the absolute value bars around it, just in case it's not a positive to begin with. Good, and then because it's indefinite, don't forget your c. Now we can just substitute the u value back in there. So we're going to get natural log, absolute value of 2 plus sine x plus c. In this case, 2 plus the sine of x. We know sine of x is between -1 and 1. So if you're adding 2 to that, it's always going to be positive anyway. So you could drop the absolute value bars if you want to and write this instead. Okay. I would take either one of those answers, right? They're both technically correct. And honestly, I would rather you have the absolute value bar so that I know that you remember that it's supposed to have them to begin with. Okay. Any questions on that one now? All right. So like I said, that's it, right? We've gone through the entire exam review. Final exam will be very, very similar to that. So just expect you're probably going to have some limit questions. You're going to have one derivative that you have to use the limit definition of a derivative to calculate. You're probably going to have a tangent and normal line question where you have to find the derivative, find the slope, write your equation of your lines. You're going to have an optimization problem. You're going to have a related rate problem. You're going to have some derivatives to take, some integrals to take, and most likely like a particle motion type of problem, right? So those are the things you're going to need to know how to do. But again, if you work through the exam review and you know how to do those problems, you should be fine for the final exam, okay? Any questions, comments, concerns now before I let you go? Yeah, so it'll be 10 questions. Again, with some of the questions have multiple parts, but it should be about the same length as what the practice exam is. Distance formula is an option for an optimization problem, so be prepared for it, right? There was one on one of your tests that. So just, again, I don't know for sure. And the other thing I will tell you, All the tests, I've given everybody the same version. The final exam, I have multiple versions of. So it could be that one person's optimization problem is a distance formula, somebody else's is a box, right? I tried to, switch it up between exams, keep them as similar as possible, but the types of problems that you have might be slightly different from somebody else, okay? Any other questions? All right. So it's been a pleasure teaching you all this semester. I hope to be able to teach you again in the future. It might not happen because I know, this is Calc 1, and I haven't been teaching Calc 2. I'm definitely not teaching it next semester. So unless I get a Calc 3 somewhere along the line, I probably won't see most of you again. If you ever need anything, though, always feel free to reach out. I'm there. If you have questions about your classes next semester or anything, definitely reach out and let me know that. Good luck on your exam for my class. Good luck on your exams for all your other classes. Hope everybody has a great summer. And again, if you have any questions between now and when you take your final, please let me know. I'll be happy to sit down and meet with you, and we can go through whatever you need to. Okay? So have a great weekend. Good luck next week, and I will talk to you all later.